Hey everyone, I'm asmollizard, and today you get to delve into my mind as you try to solve this math question where you are required to integrate secant x raised to the power of 6. A bit strange, a bit impossible, and it is true it is impossible if you don't know the technique or the trick behind it. And you can actually find that technique if you do some proper analysis, and it's quite simple. Alright, now first you have secant x and you have raised to a power. So the first thing that comes to my mind is there an equation for us that involves secant x and that is raised to a power? Well, we have in our mind, or in my mind, is the Pythagoras theorem, where, well, how to derive it is start off with the basic sine square x cosine square x equals to 1. From there, obviously there are two more different equations you can get. One is divide by cosine square, the other divide by sine square. So if you divide by cosine square, you get tangent square x plus 1 equals to secant square x. If you divide by sine square, you then get back, well, very simple, 1 plus cotangent square x equals to cosecant square x. So this is how you should really be deriving your formulas for your Pythagoras theorem, starting with sine square plus cosine square. And well, for this question, we're not really interested in cosecant nor in sine, but we're interested in secant square x right here. Alright, so let's take that equation and see what we can do with it. Alright, so we have secant power 6, and here we have secant power 2. It's quite obvious that, well, we're either going to get pure tangent x if we're going to do secant power 6 x, or we're going to do secant power 4 x, right? But whatever it is, we can try out the different ways. If we do secant power 6x, we know we're going to get tangent square x plus 1 whole thing cubed. And, well, that gives us nowhere. Because we have everything in tangent, powers of tangent, and it doesn't really help us. We will just be equally stuck. Alright, so definitely not going to do secant power 6x. How about we try substituting secant square x? If you try just substituting secant square x, we will then get secant power 4 times whatever that is remaining. Still not possible. You're short of one step, but the next step is actually the same as the next part, where, alright, we know that we can't just simply substitute secant square. Can we substitute secant power 4? Alright, and what you notice is this. If we substitute secant power 4, it's basically this whole thing square, this whole thing square. From here, what we are left with is, because we only substitute secant power 4, we get secant square x, and then tangent square x plus 1 whole thing square. And what do you notice? Over here, you get, well, varying powers of tangent x. Alright, and of course, constant plus 1. What do you notice? You have a factor secant square multiplied to each of these factors. And what is so special about secant square x and tangent x? You notice that secant square x is the derivative of tangent x, which means that we are able to integrate this form because we have tangent x raised to power n, we have fx power n times f prime x, and we know that we can integrate this to give us fx raised to power of n plus 1 over n plus 1 plus c. As such, that is the trick behind this question, and well, it's the instinctive method that I have in my mind. Alright, so let's get this done. Secant x times secant power 4x. Substitute secant power 4. We need to isolate secant square x. Now, simply 1 plus tangent square x, or tangent square x plus 1 is both are the same. From here, just do your simple expansion. I'm gonna basically simplify this early on. Alright, and you notice, first term, very simple, integrate secant square will give us tangent x. Second term, we have tangent x raised to the power of 2, tangent x square, and we have the derivative, so it's simply tangent cube x over 3, and because we have the constant 2 in front, we have 2 tangent cube x over 3. Last term, tangent x raised to the power of 4, so we get tangent x raised to the power of 5, divided by 5. And don't forget the man, the myth, the legend plus c. Alright, so this is how we solve secant 6x. In fact, you can even do this for secant 8x, secant 10x and all that, just that obviously your expansion will be larger. In fact, if you're dealing with any powers of secant, this is the main idea that you should be taking. Substituting tangent square x plus 1. Although, of course, for secant nx with the odd number is slightly more tedious. You need to involve, let's say, secant cube and all that, which again takes a longer work and won't be really tested in the HTML syllabus. What other possible integrals would use this? If you notice, cosecant squared, right? If you notice that if you're to, let's say, differentiate cosecant, you're gonna get minus, if you differentiate cotangent x, I kind of mixed that up, you're gonna get minus cosecant squared x. All right, so you could possibly get cosecant squared x or cosecant raised to the power of 2n, and you'll be using this idea as well. On the other hand, we can either give you sine squared or even cosine squared as well. All right, so this will be the idea for the following integrals, where we use the Pythagoras theorem to help us solve, and also use the idea of fx power n times f prime. All right, so that is how we solve the integral with my lizard brain.